Okay, let's look at radius, arc length, and central angle. So let's review what all these things are. So we have a circle. We have our center. So going out from the center is our radius. And then we have just an angle. This is called a central angle. We're going to call it theta. And then our arc length right here is going to be called S. So this is our arc length. Okay. So there are all the parts that we need. Radius, theta, which is our central angle, and then S, which is the arc length. So think about the arc length as the crust on the pizza, okay? So for a circle with radius r, a central angle theta in radian measure, so we may have to convert. So we'll look at that in a minute. Intercepts of an arc length S given by S equals r over theta. So sometimes we will have to rearrange this formula, but we have arc length equals our radius times our central angle. Note that if r equals 1, then s equals theta, and the radian measure of theta equals the arc length. Okay, so one thing we need to remember is in order to convert, if we have it in degrees and we want it to radians, make sure you're going to multiply by pi over 180 if we need to. So that was in the last lesson. Okay, so let's see what our first section contains. It says, find the radian measure of the central angle of a circle of radius r that intercepts the arc length s. So we have arc length s, radius r. We want to find theta, the central angle. So we do have the formula S equals R times theta, but we don't have theta. We want to find theta. So we're going to solve this for theta. The way you do that is go back to literal equations, and if we want to get theta by itself, we divide by R. So theta is going to be found by doing S over R. So S is our arc length. So let's look at what we have here. So theta is found by doing our arc length S, 10 feet over 22 feet, which would reduce down to our feet would cancel. 5 over 11. We need to put that in the calculator because we want to find the angle measure. So we are going to divide 5 divided by 11, which is 0.455 radians. Okay, so make sure to use the symbol or the radian. So this is our arc length, okay? Arc length here, radius here. So this is actually our angle in radians. Okay, let's look at the next one. We have 80 kilometers, 160 kilometers. So to find the angle theta, we do S over R. So S is 160, R is 80, and we're in kilometers. So our units of measure will cancel, zeros will cancel, we get 2 radians. Okay, let's go to the next one. Find the length of the arc on a circle of radius r intercepted by a central angle theta. So we have a radius. So let's think about this in terms of our circle. We have the radius. We have the angle theta. We want to find S, question mark. That is our central angle, our arc length. That is our crust that we want to find. So in this case, we'll be able to just use our regular formula that they gave us. S, which is what we want to find. we have our radius and we have theta, so we can go ahead and do that for our first example. We have 9 feet is our radius. Oh, goodness. I don't know where I went. So S equals our radius, which is 9 feet, times pi over 3 radians. So when we reduce that, that's ended up being 3 pi feet. We want to go ahead and find out what that is, which is 9.425 feet. Because feet didn't cancel out, and we're actually finding arc length, which is in feet. And the next one, we have 12 centimeters, and then we have 135 degrees as our angle. So S equals the 12 centimeters, and then times 135 degrees. But the deal is with degrees, we have to use our conversion. Our conversion is the pi over 180 degrees. So we can let the calculator do all the work for us, and we'll end up getting centimeters. But we multiply 12 times 135 times pi over 180 in that order, and you should have gotten 28.274 centimeters. And you can check that in the calculator. Okay, the next one, find the radius. So this time we're finding radius. We don't know what the radius is. With arc length S and central angle theta. So we have our circle. We don't know what R is. Question mark. We have the arc length and we have the theta. We don't know what S is. So when we use our formula, S equals R times theta, we want to find out what R is. That's what we're solving for. So in order to solve for R, we got to get rid of theta. So divide by theta. So we get radius is found by doing the arc length divided by the angle, theta. So R equals 3 over 4 pi over 3. So we need to put this in the calculator. We can put it in just like that. So let's do that. I'm going to use my fraction button. So it is 3 over, I need another fraction, 4 pi over 3. Okay, that comes out to 0.716 meters. I forgot to put my unit there to know that meters will be our unit. Okay, the next one, we have radius equals, it says S, which is 8 over the 330 degrees. But with the 330 degrees, I have to convert that. So I'm going to convert it down here, times pi over 180. So anytime it's in degree, you have to multiply it times pi over 180. I could have changed it before I even entered it into the formula and done times pi over 180 and then plugged it in, or just put it all in to that one equation. So let's go to our calculator and do 8 divided, oh no, I want to do the fraction. 8 over, I want to do the 330 times pi over 180. 1.389. And it'll be in inches because I should have put inches here. So 1.389 inches. Okay, let's look at our last problem. Find the distance between the cities. Assume that the Earth is a sphere of radius 4,000 miles, and the cities are on the same longitude. One city is due north, the other one city is due north of the other. So if you think about it, we have our circle here. Our radius is 4,000, and they're on the same longitude. So let's say this is Texas, and then due north is our Nebraska, our Omaha, Nebraska. So we know what the degree measure is. We want to know what the measurement is between the two cities in miles. So we want to find S. So S is found by doing radius times theta times the angle. And these are in degree measures. So we are going to have to convert them to the pi over 180. But we can do this in the calculator. S equals our radius is 4,000. Our degree measure, we want to find the distance between. So we want to find the difference between them. And I want to do the biggest one first. So 41 degrees, 15 minutes, 50 seconds, minus 32 degrees, 47 minutes, 39 seconds. But I do have to convert them, so I'm going to do times pi over 180. And I can have the calculator do all the work. So let's go over to the calculator and put that in. So 4,000 times, we have 41. Remember the angle? So second apse, where you get the angle, degrees, 15 minutes, 50. So seconds, remember it's the alpha plus, and then minus 32 degrees, 47 minutes, and 39 seconds. And then we want to multiply this times the conversion factor of pi over 180. Okay. And that is how we get it to be the distance. So 591.298 miles. Okay, that is it for this lesson.